Welcome everybody, Sheldon here with Data Systems Architecture, and this is the first video in our Advanced Architecture series where we're going to be discussing high-level concepts that you should be considering while you are designing your data systems, or if you're an engineer, these are concepts you should be aware of to help you implement better code. And we're starting with was going to seem very basic, but this is something that these are things that are not really considered a lot in general as sort of an abstract concept. They're just sort of taken for granted. So I wanted to start with a foundation of just talking about data integrity, starting with the idea of having a source of truth in our data system. So if we're using a modern data warehouse architecture, for example, then we have multiple representations of our data in different places across our entire system. For example, we may have raw data inside of a data lake that would live on a cloud system, maybe Amazon S3, or inside of a object database like MongoDB or Scylla, right? We have some raw data. And then we also have use case specific data warehouses or databases that take that data, they transform that data into a particular schema to facilitate particular queries. And these queries are what power our applications or give our analysts and data scientists the ability to do their work. And so because we now have multiple representations of our data in different places in our system, we need to be cognizant of what is the source of truth of our data. Oftentimes, it is not our copy of the data. It could be an external data set that we have imported. And if there were any issues when that data was originally imported, then we are out of sync with the source of truth. So, for example, if we were working with an external API to fetch data periodically, and we were to miss some rows, or we were to somehow modify that data while we were writing it into our database, then that data would be out of sync, and we would have no longer, we would be having problems. Now, another example I already talked about would be using an organizational data lake where all of the raw data goes into the data lake, and then separate databases work with that data to form their own schemas, and these stay synchronized. And the most common scenarios for running into data integrity problems are crashes and deployments in your ingress code. So if you have an ingress system that looks like this, where you are taking records from a data source with a custom script or some application code. Maybe it's periodically fetching new records from the data source, or maybe the data source is being streamed and you're subscribing to a Kafka topic, something like that. And your script, your app is then writing that data to the data sink. If you have a crash of this application, or you deploy a new version of this application, maybe some schema changes, or you need to reduce the memory on the virtual machine, or whatever it is you're doing, the internal state that keeps track of what data has been written and what data has not been written while it's in flight in this system is a very sensitive thing, and many engineers will not handle this properly. So there are solutions to this problem, but right now we're not getting there yet. We're just talking about data integrity and where these problems can arise. So let's go back to some other loss scenarios while you're performing database administration tasks. So if you are doing things like adding users and removing users, and then you accidentally remove the user that's associated with the ingress code, right? Or associated with one of your data scientists, right? That could incur data loss because it could cause a crash in your pipeline. Or if you were to accidentally drop a table, it's just silly stuff like that. It does happen, and we need to be prepared for those scenarios. Additionally, during cloud operations are very stressful and cognitively intensive. And this is because cloud operations are sort of do or die in that if there is a mistake during a deployment, oftentimes this can result in data loss if you haven't done your due diligence and prepared for that kind of failure in advance. So for example, let's say that we had an Elasticsearch cluster where we had replicas of data on different indexes, and then we were to start an upgrade or we were going to start adding nodes to that Elasticsearch cluster, decommissioning the old nodes, and then maybe the new nodes have better hardware or less expensive hardware or something like that, right? This kind of operation is a very common source of data loss, especially if you can't shut down the ingress to your Elasticsearch database while this is running. And so these kind of cloud operations where we're adding and removing nodes or destroying and creating resources in our accounts, very risky. We should be planning these things in advance. Ultimately, no matter how good we think we are at managing our data pipelines and our cloud automation, all that kind of stuff, if our data is critically important for one reason or another, then we need to be building data integrity verifications and have this scoped out as part of the work, part of the level of effort for your data project. And so what I mean by that is by writing some custom code that will continuously scan your copy of the data versus what is at the source of truth. So for example, let's say we can select a random unique ID for a row inside of our ClickHouse database where we've copied some data from an external API. And then we would query our ClickHouse database for that unique ID. And then we would also query the API where we originally got the data for that unique ID. And then we would verify that the results match, verify the results are still valid. And if we start having mismatches in this random integrity verification step, then this needs to be throwing some kind of alert, and people need to be looking into what the cause of the problem is. This of course is a lot of extra work, but if your data is sufficiently critical, then this is something that needs to be planned as part of your data project. So this summarizes all of the things I wanted to discuss about data integrity. Please continue to watch the other videos in the series so that we can have a shared understanding about some advanced architectural principles, and I will see you in another video.